Hello dear learners, in this video lecture we will discuss about n queens problem and we will solve it using the backtracking algorithm. So first let us look at the problem statement. So the problem is to place n chess queens on n cross n chessboard so that no queens are attacking each other. Okay, so suppose this is your chessboard. This is 4 cross 4 chessboard. Okay, so here you have to place 4 queens, and those queens should be placed in such a way that no queen is attacking any other queen. And if you see here, you can verify yourself that no queen is attacking any other queen. Okay, so if you look at here, this queen is not attacking any other queen. Similarly, this queen is also not attacking any other queen. If you look at this queen is not attacking any other queen, right? Similarly, this queen is not attacking any other queen. So all the 4 queens are placed in such a way that none of them is attacking any other. Okay, so the solution to this 4 queens problem, it is 0 1 0 0. So 1 means in this first row the queen is placed at location 1. Similarly, in the second row the queen is placed at location 4. In the third row, queen is placed at location 1, and in the last row the queen is placed at location 3. So we have to provide such kind of an output. Okay, so the algorithm has to tell whether the queens can be placed in such a way that no queen is attacking each other, and if they can be placed, then what is the arrangement. Okay, so if we try a naive algorithm to solve this problem, then how can we work? The naive algorithm will produce all possible configurations of queens on Q. What is Q here? Q here is the chessboard. Okay, so it will try to generate all possible combinations in which the queens can be placed on the chessboard, and then it will print a configuration which satisfies the given constraint. So what is the constraint here? No queen is attacking any other queen. Okay, so this is the constraint which should be satisfied. So if you look at this naive algorithm, it is saying that it will continue trying configurations. So while there are untried configurations left, it will generate a configuration and it will check whether that configuration, in the configuration the queens attack each other or not. Okay, so if they do not attack each other, then it puts that configuration into the solution. So it is producing all possible solutions and then placing the feasible solutions into the solution set, and it is removing the unfeasible solutions. Okay, it is removing the non-solutions. Okay, but we will solve this problem using the backtracking algorithm. In backtracking algorithm, we will not explore the state further if we found that this is not satisfying the constraint. So we will not go beyond this level. We will not look at the branches of this state, right? So we will simply backtrack from here. Okay, so what is the idea behind this backtracking algorithm? The idea is that place the queens one by one in different columns starting from the leftmost column. Okay, suppose this is your chessboard, and suppose we want to solve we have a 4 cross 4 chessboard and we want to place 4 queens in this chessboard and the constraint is no queens are attacking each other. So we will place queens one by one. So we will pick the first queen and then we will place it in column starting from leftmost column. So we place it here. Okay. Then when we place a queen in a column, we check for clashes with already placed queens. So this is the first queen which we have placed. It does not have any clashes with any other queen because there is no other queen, right? So I think I should write it here somewhere. Okay. Yeah. So we have placed the first queen. It is not clashing with any other queen because this is the only queen which we have. Okay. So then we will place the next queen. Okay. Next queen in the next column because we are starting from the leftmost column. So when we place this queen here, then we will check for clashes. Okay. So in this current column, if we find a row for which there is no clash, then we will mark this row and a column as a part of this solution. Okay, so now if we place this queen here, now this is in clash with this, right? So this is not a proper place to place the queen 2. So we will, what we will do, we will go to the, we will keep ourselves restricted to this column only, and we will select rows one by one till we find a row in which there is no clash with already existing queens. Okay, so here also there is a clash. We will move to the next. Now there is no clash. Okay, so this is the this is okay. So now let us place the third queen in the next column. Okay, now there is a clash here, so we will remove it from here. We will go here. Now there is a clash here, so let's move here. Again there is a clash. No, again there is a clash. So it means we have to change the place of this queen. This queen is not in a proper place. Okay, so we have to backtrack. So let's place this queen here. Okay, so now let's again start. This is okay, not okay. This is, I think, okay, right? Yeah, okay. So now we pick the fourth column. We place the queen here. There is a problem. Here is also a problem. Here is also a problem. Here is also a problem, right? So we have to backtrack. So we go to this column and check the next row. Okay, so if we place this queen here, here is a problem, here is also a problem, here is also a problem, here is also a problem. So again backtrack, go here. No, this is not a feasible solution, so backtrack. This is the last option which we have already explored for this column. Okay, so it means we have to backtrack here also. So you see, from the last column, recursively we reach the first column, we reach the initial state, and we have to change the position of first queen. Okay, so okay, so if again now this is not in clash with any other queen, so if we place the second queen here, there is a problem. Here also is a problem, here also is a problem, here it is okay. Okay, now let's go to the third queen. Okay, third queen can be placed here, and I think it is not having any clash. Okay, let's go to the fourth queen. Fourth queen cannot be placed here, it cannot be placed here. Can it be placed here? Yes, this can be placed. Okay, so in this way, using recursive backtracking, we found the solution for the 4 queens problem, right? So here I will now draw the search space, okay, so that how we are backtracking it, this thing can become clear. Okay, so again this is a 4x4 chessboard, and we will do the same problem, but now we will also analyze the search space tree. Okay, so yeah, let's start at the beginning node. Okay, so this is suppose beginning, and here we will consider the placement of first queen. Okay, so let's say queen 1. For queen 1 we have, it means we are in this row. So for queen 1 we have 4 options, right? And we pick the very first option, this one. So we place queen 1 here. Okay, and this is okay. This is not clashing with any other queen. We do not have any other queen. Okay, so this solution is okay. So let's say this is position 1 comma 1. Let's number these positions: 1 2 3 4, 2 3 4, right? So it's okay, we have found a solution, right? Then okay, so now first queen has been placed. This next level in this tree, it represents the placement of queen 2, right? So queen 2, again for queen 2 we have 4 options. Queen 2 can be placed here, here, here and here. And if we place it here, there is a clash with queen 1. If we place it here, there is also a clash. If we place it here, this is okay. So it means this is the feasible solution. 2 comma 3 at position 3, right? We have placed queen 2, right? Okay, so now we go to explore its children. It means now we are looking at, we have looked at this, now we are looking at this column. It means now we are trying to place queen 3. Okay, so for queen 3 also we have 4 options: 1 2 3 and 4. Okay, so if we place queen 3 here, it will clash with queen 1. If we place it here, it will clash with queen 2. If we place it here, it will clash with queen 2. And if we place it here, it will clash with queen 2. Okay, so it means here we do not find any feasible solutions. So all, if we try this solution, we have to backtrack. Okay, again we come here, we have to backtrack. We come here, we have to backtrack. We come here, we have to backtrack. Okay, so it means this 2 comma 3 is not giving us a feasible solution. Okay, so we have to backtrack. From here, when we backtrack at 1 comma 1, okay, so it means we have solved for queen 1. We have to look at the next option for queen 2. And what is the next option for queen 2? It is 2 comma 4, right? We have already explored it. This was not giving us a solution. This is not giving us a solution. Okay. Similarly, let me use use lesser space. Okay. Okay. So now we are exploring 2 comma 4. So we are placing queen 2 here. Okay. So now it's looking good. It is not clashing with queen 1, right? We can explore its children. That is, we are looking at column J. And now again, column J means we are looking at the placement of queen 3. Queen 3 can be placed here, but here it will clash with queen 1. So this is not a feasible solution. It can be placed here. Is it clashing with any other queen? No, it is okay, it's good. So queen 3 can be placed here. This solution is looking good. So it means 3 is placed in row 2, right? Good. So now from here, let's go one level deeper. So it means now we are finding the solutions for queen 4. Okay, so queen 4 again has 4 solutions. It can be placed here, but there is a clash. It can be placed here, again there is a clash. It can be placed here, again there is a clash. It can be placed here, again there is a clash. Okay, so for all these children we have to backtrack to this option. Okay, it means 3 comma 2 is not giving us a feasible solution. So we have to go to 2 comma 4 again. Okay, so when we go to 2 comma 4, then the 2 comma for 2 comma 4 we have already explored 3 comma 2. It is not giving us a good solution. Let's look at the next solution, that is 3 comma 3. Okay, try to place queen 3 at location 3, but now it is clashing with queen 1, so again this is not a feasible solution. Now let's try next option, which is placing queen 3 in row 4. Again, if we do this, it is clashing with queen 2, so again this is not a feasible solution. So all these options, they are not giving us a feasible solution, so we have to backtrack to 2 comma 4. 2 comma 4 is not giving us a feasible solution, so from here we backtrack to 1 comma 1. Okay, so 2 comma 4 is not giving us a feasible solution because its children are not giving us a feasible solution. So from 2 comma 4 we backtrack to 1 comma 1. Okay, so it means we have gone back to the placement of queen 1. We have to change the placement of queen 1 altogether. Okay, so queen 1, let's say I draw it here. The next option for queen 1 is, we have already tried placing it in first row. Now let us place it in second row, that is here. Okay, so now it is not clashing with anyone. Now let's go to the next level, that is for queen 2. Okay, this is queen 1, right? Queen 2 can be placed here, but it will clash with queen 1. Here also it will clash with queen 1. Here also it will clash with queen 1. So the last option which is left is it can be placed here, right? So it is 2 comma 4. So here we place queen 2. Queen 2. Okay. So now these two solutions are satisfying the constraints. Now let us explore the children of 2 comma 4. Okay, so it will also have 3 children because 4 children, sorry, because queen 3 can be placed at 4 possible locations. Okay, so the first is this one. Is it clashing with any other queen? No, the first solution itself is good, so we can place at 3 comma 1 queen 3. Okay, right, it is not clashing. Okay, so we have solved for queen 3 also. Let us look at the next level, that is for queen 4. Here also we have 4 options. Okay, so let's look at the first option, not feasible. Second option, again not feasible. The third option, I think it is good. No clash, no clash, no clash, no clash. So it means queen 4 is good at this position, 4 comma 3. Okay, so this is how we use backtracking to find the solutions for n queens problem. You can try yourself for any other n, suppose n equal to 5, right? And try to draw this kind of a tree so that you can understand that where we are backtracking. Okay, and this is the algorithm for this n queens problem. Okay, so this algorithm is very similar to the concepts which we saw in the previous example. Okay, so I think you can better understand it very well, so I do not need to explain it. Okay, and if we try to analyze the complexity of any backtracking algorithm, the backtracking algorithms have exponential time complexity. Why? Because we explore all the possible solutions. Okay, for some solutions we backtrack, but for some solutions we go till the end. Okay, so it is although dynamic programming and greedy approaches, they are better at solving some kind of problems. They can solve some problems in time which is lesser as compared to this backtracking approach, but there are still some problems left which can only be solved with backtracking. Okay, therefore we use backtracking for for problems where the solutions do not exist in dynamic programming or greedy approach. Okay, so here in this particular example, the time complexity is 2 raised to power n, that is exponential. Okay, so this is about the n coins problem which we solved using the backtracking algorithm. Right? Thank you.